Now that it's going into the springtime, it's not really quite winter anymore, and summer is not here yet. I need to start getting to work on my second Frankenstein unit, my little tall, slender unit, where I had two of these units. They were takeoffs. I brought them home because I like the cabinets and how slender they are, which I keep mentioning, behind my RV gate. So I'm going to put a scroll compressor in here like I did the other one, and just pretty much gut the VRF equipment out of it. I wish I could just send signal into the boards and tell it to run the compressor that's in there, but it doesn't work that way. So maybe someday I'll be able to interface with the outputs, but not there yet. So there's a lot of good parts in here, though. Got a, three-phase rectifier, which they're just using, as a single-phase input. You got lots of capacitors. I like those IGBTs, all that stuff on there. I'm not sure what was wrong with this system. Expansion valves, electronic ones. I got the two fans, which I want to reuse. I took out the fan IPM, inverter power module, because remember I blew up the other one, but I didn't blow it up. It turned out to just be my little board that fried and blew the rectifier and the VFD I was using for the rectifier. And so I have the module that came out of here, and it's still good. So I'm going to put it back, and I'm going to put my module in there. It was kind of funny. I moved my board down here on the other one, thinking that the fan IPM went up there, which it does fit, but actually it did come from down here. Oh well, I'm going to make this one pretty identical to the other one. I'm going to pull this out. I'm going to cut the whole countersink in, variable frequency drive. I have the other one. It's actually, I'll just take the one out of the Linux unit. So the compressor and the VFD in the Linux unit is going to go in here. I have the identical control board I'm going to put in that I made. And it's pretty much going to be identical. And this is going to be my downstairs AC. Let's pause this teardown video for a moment and go check out the other identical unit to see how it has been doing. Check out my heat pump. I have the thermistors, probes, shoved in the vents up in my bedroom upstairs. I felt the heat kick on when I'm up there, and it's actually kind of cold out here. So temperature split is 25. I got 72, almost 71 points, and then 97 coming out the vent. Man, remember this thing? Oh, dude, it's like purring like a kitten for weeks. I haven't had to touch shit on it. It's freaking blasting out some cold ass air, and it is running nice and quiet. Of course, always when I stand behind the phone, it wants to cancel my voice and amplify the sound in front of you, but believe me, it's quiet. Here is this heat pump, little, small ass 115 volt compressor heating my water, domestic water. So it's, as loud as that. So a few minutes ago I just popped this panel loose. That's why I left the screws out so I could spy on it. I haven't really paid any attention for a while. You see that display is working fine, man. There's like no scrambling, no weirdness on that. We're on high heat. Defrost timer is at 67 minutes. It rolls over every 90 minutes and checks the thermistor, which is at 34 degrees. Man, it's blowing that cold ass air on me. And my controller's still working without skipping a fucking beat. My bad. Lift that. The IPM for the, these two fans, being the signal coming from my thing right here. Dude, this thing's just been working. Variable frequency drive should be on 60 hertz. You can see that angle. So this just served as a little update. Damn, thing's kicking butt. I wonder if it'll ever need a defrost. I'm definitely moving a pretty good amount of air through that. That thing is just kicking butt. And again, look at the temperatures. Oop, just lost the one probe, which is upstairs in that room up there. Waiting for it to come back. There it is. Almost 72. So still running about 25 degree split for heat. That is cool, man. So I know it always looks messy out here. I always see that in my videos, but I have this unit I was working on I didn't finish, and I had parts here. I was all, and a storage is just storage right here. It's just pushed up against the wall right here. Yep. So I just want to show you guys it. I just took the panels off. This time, hopefully this doesn't set apart for a whole year plus. I think it was more than that. I think it was a couple years on the other one before I actually implemented it. And the thing is, the one outside right now is working perfect. I mean, it's heating great. It actually seems like it heats better than the other one, but I think it's just my imagination. Because it's pretty identical compressor size and everything is what I made into that Lennox unit. It's a 3-ton. Upstairs unit used to be a 4-ton, and then I put the 3-ton Lennox in its place, and then this Slender that's out there now, and then so my downstairs unit is a 3.5-ton, but all my guts in this is going to be a 3-ton, so basically I'm going to be changing that to a 3-ton. So if I ever run out of capacity in this house, I'll just add like a mini split to one of the rooms and take it off the system, but I don't think I'm gonna. It does okay. So a little smaller unit usually is more efficient if you can get away with it. So, and they do like to oversize the equipment here. So anyway, not to make this video clip too long, but again, I'm going to pull out all this. I've already made a video on that where I did the identical thing. I'm going to take out the common manifolds. I'm going to reuse these as just being the one suction and the one liquid line isolation. I'm just going to run the pipes down here, repurpose the coil, repipe it, put check valves, capillary tubes for the outdoor metering device, which working perfect for heating mode on the one I have now. So not going to use TXVs or anything like that. So bringing back cap tubes. They work great. My TXV, the Goodman unit. So the whole reason I haven't also done this because I don't want to have to buy another air handler and all that stuff. And I'm going to do an experiment. I think I'm going to just put an ECM blower in that Goodman up there. Change the cartridge and the power head on the Sporlan TXV I had put in there when I first moved in. It's an R22 one right now. I'm just going to change it over to R410. And I think I'm going to just hook a 410 up outdoor unit to the old Goodman and say screw it. And see what happens. The coil is a 3.5-ton, and I'm going to be hooking a 3-ton to it, so that should make the surface area about right, going from an old recip R22 to a newer 410 scroll system. You got higher saturated coil temperature, basically, so it should kind of work, and it'll be a nice little experiment. And then when I have to, I'll buy a new air handler for that system. But since I have everything, don't need to really buy much. Why not? Okay, less than an hour into it, and I have all the electrical removed. I'll do that next. Got that electrical panel. I'm going to rearrange it and use it again to tie in all my electrical. So these are the two boards. This is the main control board. The power comes in here, power going out to things. These are each line 1, line 2, and signal wires. So you can see the beefy ones are probably going to be line 1, line 2, and then the small one's going to be the signals. And you know how VRF mini split stuff works. Ductless is what this kind of unit is based on. Got the 4 PMVs, you know, electronic expansion valves plugging in down here. It's got it filters the AC. It looks like it's got a big relay to close once it charges up the caps. So, and then over here on this one, power comes over, DC comes in. It looks like it's got a module here. They just call it IC3. It's going to be power factor correction, I'm sure. Charging up the caps. And then you got your DC bus coming over to the IPM. They got it called IPM 1 right there. And you got all the silicone on all the low voltage connections, so I can't really look at it, but I can kind of just look at this and kind of see what they're doing. So positive from the capacitor bus is going to come over to the IPM chip. And then you're going to have the negatives coming up. Look at these surface mount resistors. 2 of them. Where was I before? So rudely interrupted. So look at the size of these freaking surface mount capacitors, man. They're massive. So all the current to the compressor, which is in pulses, goes through those 2 bad boys right there. Every bit of it. So on the bottom of this module, these will be your 3 negative posts from your DC bus. And when you look, maybe I'll throw it up on the screen. Generally, a lot of these IPMs, I've noticed that they have independent ones in case you want to run things independent or whatever. So it's just to the negative IGBT for each. of the 3 outputs. The positive ones just are all common rail inside, you know, so to speak. And then this is your, looks like UWV or UVW, your 3 DC output pulse, you know, phases. So you got 1, 2, 3 right there. So these are the high voltage side, and this is all the low voltage side, all the bootstrapping, all the low input, the I input, basically all the logic that puts the 6 IGBTs or MOSFETs, depending what type of module it is. It all basically biases, you know, the one positive on, another negative on, you know, to pull to these 2 windings, and then these 2, you know, and then these 2, and, you know, every other time you get the opposite polarity and whatnot. 6 steps to go through over and over. So that's it, some diagnostics. So I noticed this one chip here, and I don't know if this chip's actually controlling all of this, but it's made by International Rectifier. So I should look that up and put that on the screen there. So if I find anything, I'll put it on and post edit. It looks like it runs on an external 4 megahertz oscillator, it looks like. Yep, so there's a lot of good parts. I like saving these. I mean, capacitors are what's the most almost the most expensive, except for the IPM modules. But out of everything else, these are what cost. So I definitely like saving them, especially if they're good. They're a little bit of a bitch to get out, but I've kind of learned over the years just to kind of just take a cutter and just cut or drill right around them, and then there's so much less mass that you a regular soldering iron, you know, can get that cleaned off. So there's like 6 nice healthy capacitors there for future projects. So I got some probably mostly optical isolators. There. A lot of those is what those are, but could be something else. But they probably are, and it's usually when you're communicating 2 different. Like some of this stuff might be kind of riding on the rails of high voltage power from the modules and stuff, so you got to isolate it. So probably what a lot of that stuff is. A lot of surface mount stuff. And that just went over here and communicated. And you can see right here, it kind of says fan pulse width modulation. And I thought at first when I saw this, hey, I could just it's probably a variable voltage going in, just give it a speed reference. Nope. PFC, see, I bet that's power factor correction control. Probably turns it on. But I notice this has a receive and transmit, and then it's got like fan 1, fan 2, speed, pulse width. Okay, so it's got it on both sides. Interesting how that just goes through. And that could just be kind of isolated and going over to here, because this header here goes to that other IPM for the fan, which I showed you in the other video. So you got these 2 legs, these are plus and minus from your DC bus. So 230 volt here, it's about 330 volt DC going over there. And then you got your common, oops, that is common on the DC negative. You got your, these 3 legs is 15 volts from the IPM module for the fan. And then it's got speed input, and then your speed back out with your feedback. So they probably, I don't know how they're doing it, because they're going to be both on the same thing. So I don't know how. So it probably doesn't have 2 independent things. And I notice it says fan 1, fan 2. Oh, that's what it is. Which I've never seen this running in that. This module, the IPM that's in here, runs both fans off 1. So it's only using the one. Only 1. I was saying there's no way it's doing 2 off of those. I know. Kind of got those signals memorized over there. So it is pretty interesting. Almost wish I would have played with it while it was powered up. Just to see. But as you can see, the compressors probably all ran by communication. Probably over to this, you know, processor over there from the one to the other. Is that the whole processor for this board? Probably is. It's not a microchip, it's something else. 78F something. A lot of, I'm sure these are optical isolators, just isolating. Oh yeah, these are all your S signals to and from. I think it does one polarity to talk to the outdoor board to the indoor board, and then another polarity go from the indoor to the outdoor. Almost all your mini split ductless do that. So you got probably 1 unit, 2 unit, 3 unit, 4. Oh, there's more than that in here. Oh, it's got other types. So 1, 2, 3, 4. 1, 2, 3, 4. And this might just be in 5, 6, but 5, 6. So I don't know why they have that there. It looks like all these parts are here. Oh, this was focusing. And but this connection aren't there. So it's got A, B, C, D, E, F. So this board is able to do up to 6 indoor ports, indoor units. So it's probably even we only got, let's see here, 1, 2, 3, 4 expansion valves. You would need 2 more if this thing could do up to 2 more. Where would they be on here? Huh. Oh, right here, right in front of me. Yeah, so yeah, E, F, A, B, C, D, E, F. So this could do up to 6, and it looks like it's got the drivers. I guess it was simple for them. I mean, they didn't waste the money on the little ribbon cable connections, but they freaking went ahead and dropped the drivers. These are all drivers for these. But I used some drivers. I might even have some up here. Is that what these are? And this is I2C serial to parallel adapters. But I have them to run those. So I have my own. I made a couple control boards to run these, even one that's like a tester. So it's pretty awesome. I gotta get back into that before I forget how it even worked. All the surge suppression and everything. Like I said, this is the filtering. Usually what I notice is when you first put power, it kind of trickle charges up the DC bus to big resistors somewhere. Or resistors. Let's see if I see them. And then what it does is once it gets kind of to a certain voltage, it closes the relay and then it supplies current. So I'm not sure if these are big relays or what these are. Filters. And so it's probably got, a couple different power supplies. There's a rectifier right there. So this is definitely needing AC power going in here to this. But since that is full voltage, that's going to be a really high voltage capacitor. So, oh yeah, 500 volt. I could probably put DC in here. DC would just pass through the chokes and just go right through and probably charge up. I've done that on a couple things, and just like I do on variable frequency drives, it works. The only time it backfires is if you hit the primary side of a step-down transformer that's needing to be AC power. It's like a dead short to your DC power. And they have a transformer here, but it's probably all off of the module, perhaps, to make smaller voltages. Just doing a little more show and tell of what's on here. Oh yeah, it's got one here too, to make all the smaller voltages. But it's probably just all switch mode off of probably charges this up first, and then it just uses switch mode off of the different taps to make a bunch of different voltages, which is what's charging into these probably. Same thing over here, lower voltages to run lower voltage stuff. But everything, there is not. Oh, pretty cool. Anyway, and one last thing before I quit this segment is, like I said, I kind of wish I could interface with that even with my own controller and just run the DC compressors that are in there. But the only negative thing about doing that is if I ever did all the work to accomplish that, to run one of these DC compressors, is had these on my home all Frankenstein. It's like I would be kind of stuck with needing that kind of compressor or those boards if ever fried later in the future. So I have several of these VFDs I'm going to put in there and just use that compressor I already have. And if a compressor dies, it's just a 3-phase compressor, and I usually come across them sometimes without even needing to buy one. Or, if I have to buy one, it's a lot cheaper than all this stuff. So on my home heat pump, I just want to keep it fairly simple with, even though it is Frankenstein, but I'm only Frankensteining it because either I got the stuff free or, I want clear up some space. Oh, here goes my daughter. She's going to want food, but probably have to put a stop to this, and maybe the next day after or so, next week I'll start cutting out all the piping. So I probably will hold off. I need to get 2 check valves and another box for the capillary tube. Being so rudely interrupted. Trying to find the box I just used for that other capillary tube, but I'm gonna have to look up. Might have it in my past video, but it's Supco capillary tube. I already calculated it. I probably showed it in my video. What I calculated for this. So I need 2 check valves and another box of capillary tube to make the heating metering device like I did on the other one. And then I'll probably wait till I get that stuff before I start opening this up so I can just do it all in one day. I got to take the compressor out of the other one and the VFD out of the other one and make another plate right here. Adapter plate I made take the plasma cutter and cut it just to countersink that little VFD right here. Well, I'm trying to finish my video, but my family keeps bugging me about dinner. Wife's out with one daughter, so the other daughter, I think I need to go get her food right now. So let me, I don't know where I just left off, but they opened the door again. But try to finish off here. This is a board out of a Frederick VRF package unit for hotels. And something interesting on the way this is I have put DC into this before and it did power up. It just gave me like a fault because it didn't, the zero crossing, you know. But, or I could put AC into it or whatever. It has a power factor correction and it's got the outputs right here for the compressor and then up to 2 fans here. And the funny thing is this is all discrete IGBTs or MOSFETs up here for the power factor using these 2 transformers. Pretty, you can tell they're wound for like high frequency. And then this is the compressor one. It's got 6 outputs here and 6 for that fan motor, 6 for this one for, you know, smaller motors. And it's got the drivers here. And notice that they got test points. And I looked it up and I already saw what these were. And here's some microcontrollers. I wish I could just give it a speed input and let it do its thing, but I don't think it's going to do that. It says motor control system. These were, I mean, you do have to give respect that these are kind of overbuilt, even though they had some glitches. A lot of it was installer user, but this part of the system definitely was pretty awesome design, I think. I kind of like how, you know, it's kind of laid out. I don't remember if I got the part numbers off all this stuff, but sometimes you have to kind of wet your finger and rub it, but I did get some of them. I know I got that one there and saw what they were. And so I could probably almost just pop out a couple like coupling resistors or something from the microprocessor and look at all these, how these are all, these test points are right there. Those are like your 6 inputs, your logic inputs, your you know, for each phase. So it's like A high and low, B high and low, C high and low. I mean, at least that'd be how you reference it, maybe in your software or whatever. It could be U, V, and W, you know, for the for the 3 outputs. So like you'll say high here and then low on this one. So it'd be like, for example, this wire, this one will pull it to plus, and it'll take this one and pull it to negative, pulse width modulated, you know, and then you're pulsing these 2 outputs at this polarity, and then you just change in the logic to do your 6 steps. Yeah, it's pretty awesome, and I might be able to hack into this, and I have a couple of them that people replaced, but they seem to still work. I tested them in a unit I had brought home, and so again, a lot of good parts on here. It's on a nice big hefty heat sink. And what my goal is, if I get it to work, I'll maybe use one of those smaller compressors. Like there's one right there. That's a inverter-driven compressor, and maybe hook it up to one of those to run my water heater one. Something that's not so critical as my heat pump for the house to fuck around with, and be able to actually run the motor. That would be cool if I can interface with it. And getting all this circuitry just right, all your bootstrapping and just all that stuff for DC motor control. It's pretty fun. Trying to find out where how I'm going to get like an interface back to, you know, because you can run them kind of dumb, unsynchronized, but if you lose sync, it kind of is trouble. But you also want to have some sort of circuit so you could kind of read the positioning off of the unused winding. You can read its relative position and know when to fire off it the next step. So I'll have to go through my microprocessor. Anyway, future project. So I just wanted to end this clip with that, but that's kind of where it is. So right now, gutted, electrical gutted. Next step will be refrigeration gutted. So I'll probably repipe all that while this is open and then build my electrical last, because I went ahead and took several panels out, which give me a lot more room in here. I probably did that last time too. And I'll probably have to pull this one. So anyway, with that, don't forget to like, subscribe, share, and all that stuff. Catch you guys later. Gotta go feed the kid.